So we are going to start our lecture number 2. It will be lecture number 2. It is 1 here, so it will be 2. DC to DC converter, input output relation of all the basic converter, that is buck converter, boost converter and buck boost converter. Okay, so we have seen the basic configuration of all the three converters, that is buck converter, boost converter and buck boost converter uh, in single pole double throw switch and pole configuration. And in that respect we have also mentioned that this pole and switch, single pole double throw switch, can be replaced by any semiconductor switching devices. Here for this description of all these three converters, we are replaced this switch and pole by BJT, power BJT, that is bipolar junction transistor, right? So these are the circuits diagram. So here that pole and single pole double throw switches are replaced by BJT and diode in all the three configurations. Now in today class we will discuss this basic input output relationship of these converters using voltage second method. Okay, so before that we will discuss that what is duty cycle. Now duty cycle is that on time divided by the total switching period, right? Now total switching period means it's T on plus T off, which is represented by TS, where TS is the switching period. Now so we can say D equals to T on by TS, so T on equals to D TS. Now again TS equals to T on plus T off, so here we will got T off equals to 1 minus D into TS. Now this is the switching pulses T on for some period, and then this is off period and it is periodically repeated. And this total time is the combination of T on and T off, which is the switching period, right? So now what we will do, we will draw on here the base drive pulse VB. So this VB is during the on period is applied in the transistor, and off period it is low, so transistor is switch off. So this is the base driver pulse which control the transistor switching on off process. So basically we will give this pulses here, VB pulse, in every configuration, right? So if we put the pulse, it is high, so transistor is on, and if it is low, then transistor is off. And we have to keep always the duty cycle is never greater than 1, right? So T is always less than 1. So we easily can see from here that duty cycle is less than 1. Now we are going further into the details of the input output relationship of buck converter, boost converter and buck boost converter, right? So in this switching power conversion circuit, we use volt second balance to deduce the relationship of input and output. Now what is basically volt second balance? Now volt second balance is basically the fact that over one complete switching period, that is this one, over one complete switching period, the total volt second applied to an inductor, total volt second applied to an inductor, that is including the magnetizing inductance of the transformer, must be 0 and in steady state. So in total period, that is T on and T off, total period, this voltage second applied in this inductor is 0 in steady state, right? So if we consider buck converter, so if you see the circuit of the buck converter, so this is the circuit of the buck converter. So when Q is on, so the diode, so this transistor is on right now because pulse is given to that transistor, which is high base pulse and the diode conducted in this direction through this inductor, then it will capacitor and load, and it will return to the negative, and the diode is in reverse biased. So this is conducting, means this is shorted, so input voltage will appear here and the output voltage V0 is appearing. So the voltage across this is basically V in minus V naught. And when it is, this base drive pulse is low, that is transistor is switched off, so this is open circuit. So what, diode will conduct in this fashion, and in that case, sorry, inductor current will flow in this fashion, and the diode is in forward biased conditions. So in that case, inductor will change, inductor voltage will change its polarity, because previously it was charging, now it is discharging. So V0 is the voltage in off condition, actually minus V0, and this total is 0 in steady state condition according to volt second balance, right? So if we see in Q1 V in minus V0, and it is T1 period, and T on equals to DTS, we have seen it is DTS, and in off period I have mentioned it is minus V0, and off period is 1 minus D into TS, and the summation is 0, right? Now we know that the voltage across this inductor is V in, VL equals to V in minus V0. Now when in mode 2, that is when this transistor is switched off, so V in equals to 0, so 0 minus V0, that is minus V0, so that's why it is minus V0. So if we simplify this, we will get V output equals to V in into D. So this is the input output relationship for buck converter. So this is the most important relationship for buck operation or step up operation. Now we will consider boost converter. So if we see the circuit, so we again applied base drive pulse in this transistor BJT, and when we have applied pulse is high, the BJT will conduct, when it is low, the BJT is off. So when it will conduct, so in mode 1, so in that direction diode will charging, it is shorted and it will return to negative. In mode 2, so this is off, means this is open circuited. So now the flow of discharging current will pass through this diode, and this diode is forward biased, and it will pass through this capacitor load and then return to negative terminal of the voltage. Now when this, it is in on period, when it is in on period, that is dTs, the voltage is V in dTs, and when it is off it is V in minus V0, right? Because if we see the circuit, when it is shorted means it is in zero potential, this is V in potential, so V in minus 0, it's V in. And when it is open circuited, so this voltage will appear here and here also, so it is V in minus V0. So it's V in into dTs plus V in minus V0 into 1 minus d into Ts equals to 0 according to the voltage second balance. Voltage second balance is voltage second in the total switching period is 0. So this is the total switching period. So from here we will get V naught equals to V in by 1 minus d. Now when d equals to 0, when d equals to 0 means, what is the meaning of d equals to 0? D equals to 0 means T1 equals to 0, because 0 into Ts into 0, so T1 is 0. So that means thyristor never switched on. So this thyristor never switched on when duty cycle is 0, right? Duty cycle is 0. That is, input voltage is appears across the output voltage, that is V in equals to V naught. Now when d equals to 1, so now d equals to 1, that is T on equals to total switching period Ts, because t equals to 1. So that means Q is not switching. That means it is not changing state from T on to T off. It is continuous in on position. It is continuous in on position, and this diode is off. So this diode is off. So what that means, this capacitor will eventually discharge through this fully. Eventually discharge fully through this resistance path. This charging current will totally discharge to 0. So this D will never be 1. It is always close to 1, which will give boost operation, because if we see 1 minus 1, that is 0. So something divided by 0 is infinity, so V0 is boosting up, and this D is never 1, it is less than 1. So we will get in the output the higher voltage than input, so it is the boost operation, right? Again we will apply this same voltage second relationship to derive the input output relationship of the buck boost converter. If we see in this circuit, so again base pulse Vb is applied in the transistor. When it is high, the transistor is on, and when it is low, the transistor is off. So when the transistor is on, so this is shorted and the path is through inductor, and this return to negative, so capacitor will discharge. Now when this is off, so the voltage polarity will change in the inductor, and the current will start discharging through this path and through this diode, which is now forward bias. So this capacitor is plus, this polarity is plus, previously this is plus. So now the polarity of the plate of the capacitor has changed. So now this is plus, and this is upper one is minus, right? So now when when the BJT is on for DTS period, so input voltage is V in, which will appear across this V in, which will appear across this diode. So it is V in minus V in into DTS. And when the BJT is off, the voltage is V naught. The voltage is V naught, and I have assumed the direction of the voltage is in this same direction. I have assumed that. Okay, so if I assumed, so this is also V0, so here the voltage will appear V0, the appear voltage will be V0. So 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 it is off period, that is 1 minus d into Ts. So if we simplify this, so we will get V naught equals to minus V in d by 1 minus d. So if we change the d0 d value, that is the duty cycle, so when d equals to 0, output voltage is 0. When d equals to 0.5, V naught equals to negative voltage appears across that V naught, and when it's greater than V0 is greater than the magnitude of the input value, that is the boost operation, and when it is less than 0.5, if I put the value here, we can see it is the buck operation. So that's it. That is all about the basic input output relationship of all the three converters, that is buck converter, boost converter, and buck boost converter, right? And in this boost converter, when we have to keep one thing in mind, that is this when this BJT is off, the diode started discharging through this path, right? So this is V naught, and here it is V in, so V in minus V0. Okay, so which is help to which is help to boosting up the voltage in the output, right? And in case of buck boost converter, when it is off, so this V0 will eventually appear here, so actually eventually appear in this inductor V0, and in that case this capacitor will change its polarity, right? These two concepts we have to keep in mind. Apart from that thing, that when the inductor started discharging, the voltage polarity also changes in this inductor. So this is all about the input output relationship of all the three converters. In our next class, we will discuss in details the buck converter or the boost converter in our lecture number 3. Thank you.